Welcome back everyone, Patrick here. Moving on to the next example, we are told that a cube has a side length x, and then we're said if each side is increased by y, find the expanded expressions for the change in volume and surface area. So before getting into the specifics here, let's talk about quickly just a cube in general. So a cube is what? It's like a rectangular prism, except all of the sides are the same. So there's no like height, width, and length. It's just all the same. So let's call it S. So we'll have side. We'll have this is a side over here, this is a side, and then this is a side as well. You could call it X as well, but because we're going to be using X after, I'm just going to keep this in general for any cube, right? And call these side lengths S. So what's the volume of a cube going to be? Well, the volume is just going to be, it's like the rectangular prism. Length times width times height, but because all of these are the same, S times S times S would give us S to the power of 3, right? S cubed is the volume for the cube. What's the surface area going to be? Well, again, it's a lot easier than a rectangular prism, if you remember, because with a rectangular prism, we had a different length, width, and height. All of these different areas were, for the faces, we had 3 different areas to work with. Well, now, because all these are the same, each of these faces have the same area. Notice like the area of this face on the side here, this one, it's going to be S times S, which is just S squared, right? That's the area of one face. Notice that the area of this face over here, it's also going to be S times the height in this case, which is S. So that's going to be S squared. And how many faces are there? There's 6 of them, and they all have the same area. So the surface area is just 6 S squared, like that. Right, so these here are the formulas we're going to be using. Now, what they're asking for is actually the change in volume. Okay, so let's write this. So we got the change in volume. And then we have the change in surface area. So what's the change in volume going to be? Well, it's basically going to be the new volume minus the old volume, like that. And then same thing for the change in the surface area. It's going to be the new surface. Let's just put SA here for short form. So it's going to be the new surface area minus the original or the old surface area, like that. Right, those are the formulas we're going to be using. So let's draw another cube here. Our original cube has what? It has a side length of x. So we got x, x, and then x right there. So this is the original cube, or the old cube, quote unquote. So what's the volume of this going to be? Well, it's just going to be x to the power of 3, and then the surface area is just going to be 6x squared. Right? Just as we had the s, right? We just plugged in x for the s instead. So this here represents the old volume, this represents the old surface area. Now the new cube, what are we told? We're told that each side is increased by y. So originally we had x, well now we're just increasing it, each of these sides by y, like that. So now each side is this expression, x plus y, x plus y, x plus y. Right? It's that entire expression right there. And so what's the volume? What's the new volume going to be? What's the expression going to be? It's going to be x plus y to the power of 3. It's going to be that side to the power of 3 multiplied 3 times by itself. What's the new surface area going to be? Well, notice how one area is x plus y times x plus y, or x plus y squared, and there's going to be 6 of them. So it's going to be 6x plus y squared, like that. So in this case, the side length is x plus y. So remember, the formula is s to the power 3, so now it's x plus y to the power 3 for this particular cube. The surface area formula, 6s squared, well, the s is the x plus y, so we just plug that in over here. And I'm going to keep it like this. We're going to expand it when we do it here, because that's where we're going to have to give the expanded expressions for the change. But for here, I'm just going to keep it in this kind of format. Right? So now we could just plug these in into our change formula. So notice we'll have the new volume. The new volume is this over here. So it's going to be x plus y to the power of 3 minus the old volume, which is just x to the power of 3, like that. And then let's split these up over here. So then the change in surface area, what's the new surface area? It's this expression, so it's going to be 6x plus y to the power of 2 minus the old surface area, which is just 6x squared, like that. All right, so that's how you just generally set it up. So all you have to do at this point is just simplify both of these. Right, so now it just becomes like an abstract problem. So what you want to do with these kinds of word problems is try to get it to this kind of point, to this mathematical point, quote unquote, where the word problem, it doesn't even matter at this point. Right? We just have to solve these over here. Now, the one that's going to take the most time is this x plus y to the power of 3, because we're going to have to multiply it 3 times. Right? And it's binomials in each bracket. So it's going to take a little bit of time here. So what I'm going to do, let's multiply these two first, and then I'll keep this x plus y on the outside. So we'll have x squared plus xy plus xy, right? This is yx, but keeping it, I've mentioned this before, always try to keep everything in alphabetical order if you're mixing variables, just so you can notice the like terms easier. And then y times y gives us y squared, like that. And then you could simplify this, let's continue this here. You could simplify that bracket because this and this are like terms. So we'll have x squared plus 2xy plus y squared, like that. And now from here, what we got to do is we got to multiply these two brackets here. So this is going to be quite a bit of algebra. And you just got to be very careful. All of the elements have to be multiplied by each other. So I'm actually going to continue this over here, and I'm going to write it out the long way, just because there's a lot of variables here. It's a mixture of variables and a lot of elements. So let's start off with x times x squared. So we'll have x times x squared. Then we'll have x times 2xy. Then we'll have x times the y squared, like that. And then we have to take this y and multiply it by all those elements. So we'll have y times x squared. Then we'll have y times 2xy. And then we'll have y times y squared, like that. Okay, when you're multiplying these, if you feel fairly comfortable, you can just simplify them right away when you're multiplying them. Just be super careful, make sure you're checking your work. In this case, it takes a little longer, but I feel like your chances of making a mistake are a lot lower. So now x times x squared, that gives us just x cubed. X times 2xy, notice the x and the x we can combine. That would be 2x squared, and then the 2 and then the y stay the same. Then over here, we'll have xy squared, right? Combining these. So let's cross these out as we go. And then over here, we'll have y times x squared. Again, I would keep them in alphabetical order, so I'll just write it as x squared y, right? And then notice that that's like terms with that. So it's just easier to spot after when you're going to simplify. So that goes away. Y times 2xy. Notice the y's we can combine because they have the same base. So that would be 2xy squared. The 2x stays the same. That goes away. And then y times y squared just gives us y to the power of 3, like that. And then from here, you just want to simplify all of the like terms. So notice there's no other x cubed. So that's by itself. That's done with. 2x squared y. So let's look for other x squared y terms. Notice this is not it. This is xy squared. But this one over here is the same as this one. So those two are like terms. So we'll have 2 and 1. So 2 plus 1 gives us 3x squared y, like that. So that and that go away. And then notice xy squared, it's like a plus 1, and then xy squared over here, right? The combinations of the exponents are the same. So this and this are like terms. That would give you 3xy squared. Those go away, and then we have the plus y cubed, like that. Okay. Just want to mention as well that there is a quicker way to expand this using something called the Pascal's triangle, but that's going to be in grade 11. Your teacher may or may not cover that in grade 10. When I'm doing this video, I'm assuming that they haven't covered it, right? But if they do cover it, you should end up getting this over here, right? So whichever way you do, whichever way you expand this expression, this here is what you should get. So we're not even done at this point because this, right, this expression is just this part over here. So what we got to do is we got to take this, plug it in here. So this was like side work just for this part. But that is the worst part in the whole video in terms of the algebra, I feel. So I feel like we got the worst out of the way. So this is just this, and then we have the minus x cubed on the end. Don't forget about that either. And then notice x cubed minus x cubed, those go away right there. And so what we end up with is 3x squared y plus 3xy squared plus y to the power of 3. That is the final answer for the change in volume as an expanded expression. You can't simplify that any further. All right, so quite a bit of algebra just because of this part right here to get that. I feel like that was the most time-consuming thing. And then this one, it's not going to be as bad because we're not dealing with exponents of 3. It's just an exponent of 2, so we could rewrite this as 6x plus y times x plus y. And we got the minus 6x squared, so let's multiply the brackets first. X times x is x squared, x times y is xy. We actually already did that when we did it here, but let's just rewrite it again. Right, and then y times y gives us that y squared. Then we got the minus 6x squared. Let's distribute, or actually let's simplify this first before distributing the 6 in. Now let's distribute the 6 into everything. And then notice the 6x squareds cancel out. So we end up with 12xy plus 6y squared. So those are not like terms. Can't simplify those any further. All right, so that is the change in volume between the cubes, the new volume minus the old volume. This here, this expression, is the change in surface area.